Well, hey there, guys. It's your favorite backyard geographer. Sometimes people ask, well, how do we calculate the distance and elevation when we're surveying? Well, perhaps you're doing this in a lab, perhaps you're doing this in a class. You're in the right place. Today, I'm going to show you how to calculate distance and elevation after you've collected data when surveying with an auto or manual level. So to begin, let's talk about this graph in particular. This is a normal form that I would have used when calculating survey data when I was surveying out in the desert. Now, I've already plugged in a lot of the information. So we've gone out with our survey crew. We've collected 4 different locations of the Stadia A, the Foresight, and Stadia B. But our job here is to take this information and calculate the distance and elevation. So what's done first, just to kind of paint that picture, is we would set up our tripod, put our auto level on it, and send someone out to a known location, a backsite, otherwise known as a benchmark. A benchmark has a known latitude, longitude, and elevation. So we would take our 3 readings, and with those 3 readings and the information found on the benchmark is 100 meters above sea level. I'm going to be able to calculate the exact height of the instrument or the level that I'm using. The formula for calculating the height of instrument is the benchmark, which in this case is 100, plus the backsite or the gray box number, the 4.22. So height of instrument is the 100 plus the 4.22, and I'm going to use 104.22 as the height of my instrument for the remainder of this activity. You do the same thing unless you move the instrument, so don't move your instrument. Now the other 2 numbers that are found in the white boxes, that's what we can use to calculate distance. Distance is the top, A, minus the bottom, B, times 100. So the top minus the bottom times 100 gives us 22 meters, which means that that person that was holding the survey rod was 22 meters away from the survey device. You'll notice that the Foresight box is left blank because we didn't look forward. We were only looking backwards for our reference. We document the bearing, any remarks we have. We don't have any elevation based on our Foresight, so that remains blank. So now that we have our height of instrument, we're ready to go. So we tell that person who's holding the survey rod to go out and mark station number 1. We are not looking back, so this remains blank. We're not looking at calculating a height of instrument again because we already have that value, so these remain blank. So we start plugging in our data. Stadia A, the Foresight, and Stadia B. So my job first is to calculate the distance. Well, the distance will be the top 2.955 minus the bottom 2.945. So I'm going to underline that, and I'm going to subtract the 2. And you saw my little calculator went away, so that's 2.955 minus 2.945 gives me 0.01. Well, I multiply that by 100, so I move it over 2 points, and that happened to then be 1 meter away from my location. And that will be the distance for station number 1. In order to calculate the elevation, you must take the height of the instrument, HI, minus the gray box. So the 104.22 minus the gray box, the 2.950, which gives me an elevation for that survey rod at 101.27 meters. I know I'm kind of rushing through the math and the idea here because essentially you can access the lab manual and see where this is done, and it explains different diagrams and such, but I just wanted to show the math that's done here. So let's do this again. We tell the person to go ahead and move. And we document the bearing. We tell the person to go ahead and move and pick a new station, station number 2. So here's our Stadia A, our Foresight, and our Stadia B. So how do I calculate the distance? Well, it's the top box, 3.555, minus the bottom box, 2.555. And then I'm going to go ahead and underline this and add the minus sign. And make sure that's centered. Then I bring up my calculator again, and 3.555 555 minus 2.555 gives me a value of 1. Then I multiply it by 100, so then I find out this time they were 100 meters away from me. Perfect. So now I can go ahead and move into elevation. Well, what is elevation? Elevation is always the height of the instrument, the 104.22, and I want to, oh, that's underlined. And I always subtract it against the middle box, or the foresight, 3.055. So I'm going to then go ahead, underline that, add my little subtraction sign so I can keep my style. So 104.22 minus the middle box, 3.055, gives me an elevation of 101.165. And that's how you calculate the elevation. Something that's interesting that you might want to note for yourself is that, especially when you're in the field collecting data and you're interested about how we got these different numbers, again, it's through that site. I can show you an example of that in a moment. But the difference numerically between the top and middle must always be the same between the middle and bottom. And that's how we check our math when we're out in the field. So another way to look, I'm going to leave these other ones blank. Go ahead and, if you want to solve them, go ahead and put your answers in the comments below. But I thought a great way of really just sharing this is by looking at a diagram like this. This is what I use in the lab manual. This is how I utilize my vocab. Again, to find your height of instrument, it's the back sight plus the benchmark gets you the height of the instrument. Then to calculate elevation, it's going to be the height of that instrument minus the foresight. And that's how you get the elevation here. So this is a diagram that I created just for my lab manual so you can experience that in the field, as it were. Well, I hope that was helpful, a different way to visualize this math. Be sure to like this video, comment below if you have any other questions. Don't forget to subscribe and check out some of my other videos. And we'll talk soon.